Hello everyone, welcome to the video on Mathematics 10. Today we're going to talk about solving a triangle. So in order to solve the triangles, we need some prior knowledge such as the fact that angles in a triangle add up to 180 degrees, as well as the Pythagorean theorem, which is useful for us to find the unknown side of a right triangle. After this video, you'll be able to find all missing side lengths and all missing angle measures in a right triangle in order to solve the triangle using the trig ratios, the Pythagorean theorem, and the angle properties of the triangle. Let's try the first example question. Solve the triangle given two sides. So in this case, we are given the side lengths of 6, side length of b. We also know that it's a right triangle, but I need to find two angles as well as the hypotenuse side. What I like to do at first is I like to organize what I know and what I don't know into a visual organizer. A graphic organizer. So what I mean by the graphic organizer is I'm going to make a table like this: A equals, B equals, C equals, A equals, B equals, and C equals. So let's write down what we know of. Let's just label this side as C. Well, I don't know the angle A. I don't know the angle B, but I do know the angle C, which is 90 degrees. I do know that the side length A is 6. I also know that the side length B is 8. I don't know the side length C. So this graphic organizer tells me what I know and what I don't know. So in this case, using the information that I have, I'm going to find out the angle A, angle B, and angle C step by step. In my opinion, finding the side length C first would be easiest because we already knew that from grade 8, the Pythagorean theorem. So let's first find C. So let's use the Pythagorean theorem, which goes like a squared plus b squared equals c squared. I know that a is 6, and I know that b is 8. And I want to find the c squared. So that's 36 plus 64 equals c squared. That's 100 equals c squared. So therefore, c equals 10. So I found c equals 10. Let's put it on the box to locate that this is the number that I found. Second step is to find, well, it doesn't matter which order I go. Let's go with the A, uppercase A. In order to find the degree, the angle of A, I'm going to use the side length 6 and the side length B. Well, in my perspective of angle A, I think the side A is the opposite side, and the side B is the adjacent side. So if I want to find the angle, knowing the opposite and knowing the adjacent, I think we need to use the tangent ratio. So let's write down the tangent ratio. Tangent theta is equal to opposite over adjacent. So in this case, the angle is A, and the opposite is 6, and the adjacent is 8. So I need to solve this equation. Well, let's do arctan on both sides. So arctan and tan cancels out. A is equal to, and arctan of 6 over 8, let's find that on the calculator. And it turns out to be 36.9 degrees approximately. And I found the angle A. So let's write it down, 36.9 degrees. approximately equal to 36.9 degrees. And finally, we need to find the angle B. Now at this point, you might be tempted to use just an easy rule that, hey, angles in a triangle add to 180 degrees, so let's just use 36.9 plus B plus 90 degrees equals 180 degrees. Now, you don't want to do that because the 36.9 degrees is a number that I found, that I calculated. We call that indirect measurement. Compared to the 90 degrees, the side length 6, side length A, side length B, these numbers are the direct measurements. And when you're calculating the indirect measurements, you want to use the direct measurements as much as possible. You don't want to use the indirect measurements to calculate another indirect measurement. So in this case, for the angle B, I'm going to once again only rely on the fact that side A is 6 and side B is 8. So in the perspective of angle B, I think we can call the side B as opposite and side A as adjacent. So we're going to use another tangent ratio. So write down the formula. Tangent theta is equal to opposite of adjacent. And in this case, the angle is B. And the opposite is 8. And the adjacent is 6. So let's do arctan on both sides. So arctan and tangent will cancel out. And if I do the arctan of 8 over 6, B is approximately 53.1 degrees. Approximately. So in this case, I found all angles and all sides. I know that angle A is 36.9 degrees approximately. Angle B is approximately 53.1 degrees. C equals 90 degrees. Side A is 6. Side B is 8. And side C is 10. And at this point, we can call that this triangle is perfectly solved. We solved all the sides and all the angles. Let's annotate the process. So use graphic organizer here. And step by step, find unknown side or angle. Using direct measurement. Let's try the next question. Solve the triangle given one side and one angle. So in this case, we need to first start off by labeling the triangle. When we're labeling the triangle, there are some rules that we want to follow. Okay? The first thing is we want to always label the right angle side as the uppercase C. And the other angles are A or B, whichever order we would like. Another rule is that the opposite sides are the lowercase of the corresponding angle. So for example, the bottom right-hand corner, we have an angle A, which means that opposite of A, this point will be a lowercase a. Opposite of B is the lowercase b. Opposite of C is the lowercase c. So this ensures that the angles and the sides are matching as well as the lowercase c always takes the hypotenuse side, so it's easier for us to, when we're using the Pythagorean theorem, to use the theorem. So after I label the sides and the angles, let's also use the graphic organizer. A equals, B equals, and C equals. A equals, B equals, C equals. So in this case, let's analyze the information that I know of. I know that angle A is 30 degrees. I know that angle B, well, I don't know it. I know that angle C is 90 degrees. And I don't know the length A, I don't know the length B, but I do know the length 12. C is 12. So in this case, I need to find the angle B, the side A, and the side B. Let's go step by step. I think it's easiest if we find the angle B first. Oh, it's a very simple fact, though we know that A plus B plus C is equal to 180 degrees. So let's just plug in the numbers. 30 degrees plus B plus 90 degrees equals 180 degrees. So we can easily say that B is equal to 60 degrees. Once again, just like the previous question, I'm happy that I found that B is equal to 60 degrees, and I'm quite certain that I didn't make a mistake there, but still, I'm not going to use the fact that angle B is 60 degrees when I'm solving this question. I'm only going to solve this question using A, C, and the lowercase c. Now let's find the lowercase a. In order to find the lowercase a, I want to use the angle A, 30 degrees, and the side C. So it means that from this angle, 30 degrees, my lowercase a is my opposite side. And I also know that hypotenuse is 12. So which trig ratio uses the angle, the opposite side, and the hypotenuse? Well, I think it's pretty simple. It's sine. It's a sine ratio. So let's write down the formula for the sine ratio. Sine theta is SOHCAHTOA, the opposite over hypotenuse. So in this case, the sine of 30 degrees is equal to opposite is A and the hypotenuse is 12. We just need to solve this question, solve this equation. In order to isolate the variable A, I think we can multiply both sides by 12. So that's going to be canceling out the divided by 12 and times by 12. So it's going to be 12 sine of 30 degrees equals to A. And of course, I want to use a calculator for this. 12 sine of 30 degrees, and it turns out to be 6. Apparently, there's no decimal points here, so this means that this is an exact value. So A equals 6. I'm happy that I got A equals 6, but still, I don't want to use that fact. So let's move on to the next part. The last number that I need to find is the lowercase b. Once again, I'm going to use the angle A and the hypotenuse C. And now I want to find the adjacent. So which ratio includes the angle, adjacent, and the hypotenuse? SOHCAHTOA, the cosine. So the cosine theta is equal to adjacent over hypotenuse. And the cosine of 30 degrees is equal to, adjacent is b, and the hypotenuse is 12. So once again, we multiply both sides by 12, canceled on the right-hand side. So that's 12 cosine of 30 degrees is b. And let's use a calculator. 12 cosine of 30 degrees is approximately 10.4. So let's write it down, approximately 10.4 on B. And let's put a box around it. And yay, I found all three angles and all three sides. Once again, let's annotate. The only edit part in this question is the fact that we're labeling the triangle ourselves. So label the triangles. So when we're labeling the triangles, first we want to make sure that the right angle takes the uppercase C and opposite side and angle have matching letters. So using these two rules, the right angle takes C, and the opposite of the right angle takes the lowercase c. And all the other letters and all the other sides are also following the same rule. And once again, use graphic organizer. And solve for all sides and angles. And once again, only using the direct measurement. So to summarize the lesson today, the solving a triangle means that we're finding all three sides and all three angles. In order to do that, we've learned the tools from before, from this year, all together. One, we're using the SOHCAHTOA method, the trig ratios, as well as the Pythagorean theorem that you learned in grade 8 mathematics, as well as the angle sum of triangle is 180 degrees. So in total, we have 5 tools to help us solve the right triangle. You need to decide which tool is needed at each position, and you need to use that. One way to check your answer is to check that the longest side is the hypotenuse. So if the side length that you found do not align very well, or if any of the angles are greater than 90 degrees, the chances that you made a mistake. So make sure you go back and check. Thank you for watching this video, and I'll see you in the next one.